This is a problem that you should have done. If you haven't done this, make sure you pause the video. So we want to find the derivative of this function. This is a nice linear function, so the derivative is not going to be overwhelming in terms of the types of calculations that we have to do. So the derivative of g at an arbitrary value for x is the limit as h goes to 0, g of x plus h minus g of x. That is going to be equal to the limit. Well, plug in x plus h into the 3x minus 7 function. So 3 times x plus h minus 7 is what we get when we plug in the x plus h into the 3x minus 7. And then in for g of x, we type in 3x minus 7. And then it's a matter of algebraically simplifying from here. The limit becomes 3x plus 3h minus 7 minus 3x minus 7 all over h. That's when I combine like terms. When I start to simplify, the 3x from the first bracket and the minus 3x from the second bracket are going to cancel each other out. The minus 7 from the first bracket and the minus negative 7 from the second bracket are going to cancel each other out. So our numerator is only going to have a 3h left in it, and our denominator has just an h. Obviously, this is an indeterminate form, but we can simplify 3h over h pretty easy. That's just 3. Now, there's no variable to plug in there. So plugging in 0 into h, there's no h there. So the limit of a constant number is simply a constant number, and therefore we get 3. So the derivative of g at an arbitrary value of x is equal to 3. Let's go ahead and graph that. Not just the derivative, but also the original function. I have graphed both the line g of x equals 3x minus 7 and also the g prime of x equal to 3. And if you think about moving a point along our function, what is the slope at every single point? Well, the slope of the tangent line is going to be 3 at every single point because we're moving along a line whose slope is 3. That means at every single point of the derivative, since the slope of my original line is 3, the output value of the derivative will be a constant of 3. We can move this point along no matter where we're at, and we get a tangent line, which is exactly what our actual line is. In fact, if you think about how this works, I've highlighted the tangent line in green. I've made the original line in red, just slightly bigger so you could see out the outside of it. And as you go around this line, the tangent line stays the same because it is the line of your graph, g of x. So constant slope of 3 means that the rate of change is a constant 3. So hopefully that makes sense.